What's on television tonight?
Shh, it started. Sit down and get comfortable. You're late. The universe has begun. It's officially 13.8 billion years old. But, so you don't lose track, we're going to rewind the film to start the story. At the Big Bang. To get an idea, a small idea, a very, very small idea of what the Big Bang could have been like. The best thing is still to throw away common sense, your brain, the concepts of beginning and end, and the trash can itself. And between each word of the previous sentences, to bang your head against the plank wall. Because when you start this story, you're always a little bit late, facing this wall, a limit that isn't zero. Our knowledge vanishes between the inaccessible zero instant and the present moment. It's either nothingness or the unknown. Because as far back as we can go, the universe has already been born at zero. This wall, located at 10 to the power of minus 43 seconds after the Big Bang, is simply the instant before which our equations start to break down. In front of this wall, the baby universe defies physics laws. Density and temperature are infinite, losing all meaning. Physicists call that a singularity, with the universe hiding behind it. And when it finally opens, the observable universe is confined. In a tiny volume millions of billions of times smaller than the size of an atom. All that exists, has existed or will exist, atoms, planets, stars and galaxies everywhere is potentially gathered at this point. In this universe, nearly all mass exists as immense energy, with no solid matter. The temperature reads 100,000 billion degrees. And from this tiny point, in an incredibly short amount of time, the baby universe goes through a growth spurt. This is accelerated inflation. It begins to swell and expand to unimaginable proportions. It would be tempting to picture the expanding universe as a kind of point suspended in a dark, boundless void. But there is no around the expanding universe, no outside. You can't admire the Big Bang from a distant observation post. There is no place to withdraw to. Outside, there is no place to watch the show. Everything has front row seats. Everything is inside the blockbuster. The universe is not expanding into a pre-existing void. It creates its own space as it expands. The Big Bang is not something that happened inside the universe. The thing that goes bang is the universe itself. And in a fraction of a second, it laid a solid foundation. Matter, energy, space and time. And four fundamental forces, four fantastic ones to rule them all. They're the conductors. They set the rules of the game and are responsible for all the phenomena we observe in nature. The first to unfold is gravity. Endowed with the power to attract matter, it is a force that bends, stretches, pulls and tugs at the threads of the fabric of space-time. It's what makes time pass more slowly where the curves are steeper. It explains how two bodies attract each other but not why people fall in love. Then comes the strong interaction, which holds atomic nuclei together and cements matter, closely followed by electromagnetism, which governs light, electricity, magnetism, and chemical reactions. Then finally, the weak interaction, which is behind radioactivity and, among other things, allows stars to shine. During these first millionths of a second, the universe is a primitive, hellish soup. The elementary particles moving here have speeds close to that of light. A single electron can contain as much energy as a high-speed train traveling at full speed. Matter there takes the form of a uniform mush bathed in radiation and without any kind of structure. And if you didn't understand everything from the beginning, it just means that in the end, you're actually sane. Because losing your bearings is always the price to pay for going below the billion-degree mark. 3 minutes have passed since the Big Bang. The universe is now cold enough that radiation no longer breaks the internal bonds of atomic nuclei. What is called primordial nucleosynthesis begins. And after 20 minutes, when the temperature drops below 350 million degrees, it's already over. The fusion reactions stop and leave us with a universe made up of 75% hydrogen and 25% helium, and subjected to incessant agitation that prevents any light from passing through. The light there is constantly absorbed, re-emitted, absorbed by an incandescent and opaque fog that will remain 380,000 years, during which space continues to expand. And when the temperature drops below 2,700 degrees, atomic nuclei and electrons combine. All the light in the world can finally travel everywhere. At the same time, the universe almost instantly goes from opaque to transparent, producing a flash of considerable intensity. The entire universe is bathed in an orange glow that will slowly fade and cool down. Because space, which continues to expand, gradually stretches the wavelengths, shifting them through red before they leave the visible spectrum. In this universe without stars, darkness returns. It will reign for 100 million years. And what will drive them away is written in this flash. That of a weary light traveling through space for 13.8 billion years. The Big Bang Theory predicted it. We found its trace. This oldest light in the universe bathes the entire sky, reaching us as a faint radio whisper that we can detect no matter which direction we look. The existence of this fossil radiation is one of the strongest pieces of evidence for the Big Bang because it doesn't rely on equations or models. You just have to look at the sky in the radio wave range to observe it. Or you can simply turn on an old television because with a cathode ray set on a channel with static. About 1% of the interference you see dancing on the screen is due to this radiation, which creates a buzzing noise. The next time you think there's nothing on television, remember that there's a channel broadcasting the birth of the universe, this primordial light. We've taken increasingly detailed images of it, on which we find irregularities. Tiny temperature differences that reveal to us the presence of small clumps of matter. Seemingly insignificant, these spots are a glimmer of hope because these tiny differences in density within the primordial matter will have very, very big consequences. These imperfections are the starting points from which the universe will take its structure. And if it had been like this, if matter had been evenly distributed, everything would have remained homogeneous and boring. Not for a very long time, but for eternity. Because without those small fluctuations, nothing would have ever happened. But that was not the case. And for a few 100 million years, in total darkness, these clumps of matter will slowly take shape. Clouds of gas collapsed, eventually igniting the first stars that brought the universe out of darkness, before finally gathering into galactic islands. By examining galaxies and their movements relative to us, we uncovered additional evidence supporting the Big Bang Theory. It is written in their movements. By observing the sky, we noticed that the farther away galaxies are from us, the more their light reaches us, as if tired, shifted toward the red. And this phenomenon is observed in all directions. And since the only thing capable of tiring out light is the expansion of the universe, we can have fun rewinding the film of the universe backwards. Starting from a vast, cold, and relatively empty world like ours means that one day you end up with something infinitely small, hot, and dense. We live in a universe that is not static, as was long believed, but dynamic. And because of this, it has a history and must have started somewhere. Let it rest, be patient. 13.8 billion years, and you will get hundreds of billions of galaxies, each with hundreds of billions of stars, around which even more worlds revolve, and on one of them, at least, humans developing theoretical models capable of predicting the existence of the cosmic background radiation even before it was discovered. And that's the third major cornerstone, supporting the increasingly solid structure of this theory. Unlike the first two, this evidence is not direct, but is based on experiments carried out in our particle accelerators, which give us ideas about the state of extremely hot and compressed matter found near the beginning of time. These experiments allow us to briefly recreate the conditions that prevailed in the first millionths of a second after the Big Bang. And to go even further back, we have the human brain, which takes over by working through the equations of physics, on paper, to go all the way back to the wall. These formulas elegantly predict the experiments carried out in particle accelerators and the proportions of atoms observed in stars. As astonishing as the Big Bang Theory may be, all observations made so far support it. The greatest show ever produced by the universe, since it produced the universe itself. A show that no one ever witnessed, yet everyone was somehow present. Because all the hydrogen atoms that make up our bodies at this moment and account for about 63% of our atoms, and 10% of our mass are almost as old as the cosmos itself. They were all formed between 3 and 20 minutes after the beginning.
Why is there something rather than nothing?
We have no idea.
But what was there before? How did the absence of everything become the first thing?
We have no idea, or not much. There are theories that say the universe bounced on itself and has been doing that for eternity. Others say it emerged from another universe, or from nothing, by borrowing energy from the void.
And from all that, if you had to remember just one thing, what would you remember?
That's crazy.
There you go, the same thing.